Hello again, everyone. This is Aaron Corcoran again, and in this tutorial, I'm going to show you how to use ThruTracker to generate an intrinsic calibration for your thermal camera. Now, the intrinsic calibration is determining the properties of the camera itself that you need to know that is going to go into generating your 3D calibration in the field. So this is going to determine things like the amount of magnification that your image is getting, the effective focal length. It will also account for image distortion, so the amount of fisheye, for example, that the lens is providing to the image. Now, you will probably only need to do this calibration once per camera type that you're using, and maybe not at all if somebody else has already done that calibration. So we are already providing calibrations for the FLIR A65 cameras, and we plan on building these calibrations for the common cameras that are used. So you might only need to do this if you're having problems or if you're using a camera and or lens that other folks haven't already been using. Okay, so the first step in this process is to acquire the images that ThruTracker is going to use to generate the calibration. So to do this, I've got an image here from when we were doing this in our lab with the FLIR cameras. And you're going to need to go to the user manual to get the detailed information on how to do that. But to give you a quick overview, what you'll do is print a checkerboard pattern on poster board and then mount that on a frame. So here I've mounted this poster board onto a wooden frame. And the poster itself, where that checkerboard is, there is nothing behind that. Now that's important because that's going to affect the thermal properties when you try to warm it up. If you had that poster board on some other object, it's not going to warm up in a way that's going to give you a nice image. So of course we're using thermal cameras here, and we need to heat up this image in order to get contrast between the black and white squares. If you don't heat it up, the thermal camera won't see anything on this poster board. So the basic procedure is you set up your poster at a set distance from your cameras, and you can use some lights, such as these floodlights here, to run them over the image. And then you will do this at different locations to get a number of images that you'll use for the calibration. Now, I have done that, and we extracted, let's see here, 30 images from a series of videos that we took with our poster board at known distances of 90 centimeters and 100 centimeters. Some of them were with the image perpendicular to the camera. Some you want to definitely have it offset at maybe a 30 to 45 degree angle. That helps with determining the focal length. So you will use your camera to take those videos and then find particular images which are representative of the different types of orientations that you want to get, and then put those images using your camera's software. We use the FLIR software to extract individual images from those videos and put them into a particular folder. So that's what we've done here. And once you've done that, then you are ready to do the calibration in ThruTracker. So we can open up some of these images just so you can get an idea. And this is reasonably good. You can see it's not perfectly warmed up evenly. You want to try to get it as even as possible. So here it's a little hotter in this corner than down here. We do have an algorithm that tries to account for that, and it can do reasonably well. So it should do fine with this image. Some of these are going to be better than others, but most of these will be usable. So this just gives you an idea of what we have to work with. Okay, so it's good to review your images and select the ones that are generally the best quality. And we did it with about 30 images, so that's a good number to shoot for. All right, once you have your images, put them all in a single folder on your computer and note where that folder is. You can try this. We have example images in ThruTracker if you just want to try it out using the example. Now, once you're ready to generate your intrinsic calibration, you're going to open up ThruTracker and go to Tools, Intrinsic Calibration. and that will open up our thermal camera calibrator app. And there's a few steps involved here. So under the file, you can save your calibration once you've generated it. After you've saved one, you can load it back up if you want to see that or do some modifications to it. You can export a camera profile, you can quit. And then in tools, there are two main steps that we're going to do. First, we'll convert our images to black and white, and then we'll do our calibration. So the first step is to go to Tools, Convert Images. And now you want to choose that folder where your images are. If you want to do it with the example, you can go into the example data and then Intrinsic Calibration and the FLIR A65 25mm lens example images. So you can just select that folder, hit Select Folder, and put it to the back here. It says Images Saved. And what it's doing is it's converting that thermal camera image into a black and white image where it's trying to detect those squares. And then it's putting it into a subfolder inside the folder where those images originally were stored that's saved as output BW. So we can go and find those images. It's a good idea to do that. So I'm going to navigate to that folder, and it just made this folder. And it took all of those images and tried to convert them into straight black and white images. So now we can open that up, and it's doing a reasonably good job of making that into a checkerboard pattern. When you consider that it was starting, we can find, it's starting with this, and then it's converting it into this. So it's doing a reasonably good job. We do have an algorithm in here. The typical way that the checkerboard algorithms work is it looks for the edges between the black and white squares. But because those edges don't come out very well, we're using a modified algorithm where it is finding the center of all of the black and the white squares on the checkerboard pattern. So what you can do is scroll through your images and check those out and see how they're working. It's not a bad idea. So in this case, that image is actually going off the screen. So we could actually delete that one. The computer, the program itself will know if it's not working well, but that one, obviously, it's not going to work because a good chunk of it is off the screen. So I can actually just delete that one. I hit the delete on my keyboard. So you can scroll through these and take a look. Sometimes you get individual white pixels. The program should be able to handle that reasonably well, or at least know when it's not going to be an image that will be usable. But this gives you an idea of the images that we're working with. If your images don't look at least this quality, then you may need to redo your image acquisition process. Okay, but obviously this is probably on the high end of quality that you're looking for, and it's okay. This would be on the lower end, but still usable. All right, so now we've converted our images, and the next step is to go back into ThruTracker and the thermal camera calibrator, and now we'll do Tools, Calibrate. Now it's going to ask you where those converted thermal images are. So I'm just going to navigate to them, and in the example data, we're going to go back to that intrinsic calibration inside this folder, and now we have our output BW black and white images folder. So select that folder, and now you can input the information for your checkerboard. In our cases, there were 14 black and white squares along the x-axis and 14 along the y-axis, and each one of those squares was 14.14 millimeters in width and height. So the default is for those examples. You can change this for your particular checkerboard that you are using. So I'm just going to hit OK there, and it says done computing the calibration. Okay, great. Now the results of the calibration, the intrinsic parameters are placed here: the focal length, the principal point, radial distortion, and the image size. So all that information is stored right here. And then you can visualize your calibration using these buttons right here. So the first one shows the residuals. So what this does is it attempts to find the center of all of those squares and in the image, in all of the images. And then using all of that data, it generates a calibration which accounts for the distance of those images, the focal length of your camera, and the distortion. Now, applying that calibration back to the image, this is asking, well, how far off is the calibrated points to the actual image points? And it's measuring that in pixels, and these values range from just under half of a pixel to about less than 0.9 pixels. So on average, it was about 0.69 pixels. If there were some particular images that were much higher than the others, you could go back to that folder, find those images, and delete them, and then rerun your calibration. So these should be in order of how those images are stored in the folder. So next, we can also visualize our scene. So this is what the result of the calibration looks like as far as where it thinks those images were placed. And I like to look at these images from above. There were 29, whoops, computer's having a little bit of lag here. There were 29 images that we used, and we can actually see which of those the computer were able to use. And I deleted one of them. There was another one that the computer was unable to use for the calibration. So it actually used, I believe, 28 or 29 of those images. And what you can see from visualizing this scene is that these images are lining up at the locations where they were measured quite accurately. So I said that they were measured at about 90 centimeters and 100 centimeters, and these are matching up pretty close. So maybe just within a few % off from that. If you are not rendering a scene, if these images were well off from that, then you probably want to add some more images, and it's really important to have some of these images that are off at an angle. That helps with setting the distance in the scene. But this one seems to have worked pretty well. And so now we have all our information, and we can just go up here and save the calibration. And you want to put the information. So these are FLIR A65, 25 millimeter intrinsic calibration. So that will save all the information that the thermal camera calibrator generated during the calibration. You can load that back up now using the load calibration command in the menu. You also want to export camera profiles for use in the simple wand calibration or an easy wand. So I'm going to also call these FLIR A65 25 millimeter, and we can save that. And profile saved. And that's it. So now we have our profile that's ready to go, and we can load that information when we are ready to do our 3D calibration. I have a whole nother video on how to do that. So that's it for this tutorial, and we'll see you in the next one.